Okay, so hello everyone. Today our topic is about series and parallel resistors. Okay, so let's move into the first part. It's about here the resistors connected into series. Okay, so if there's a figure right on the right, we can find here's a 3 ohm resistor and here's a 6 ohm resistor, right? And you can find they're just connected in a line, right, like this way. So last time we discussed about the like combined into series, right? And today we can just consider they're in one resistor like this way. So 3 ohm resistor and 6 ohm resistor, like a current must pass through the two resistors. So the total resistor has to pass at 9 ohm, like here. It's 9 ohm. Okay. So after we have many discussions and many investigation, and we find that total resistance always equals to the resistor 1 here plus resistor 2. So we can write down here total resistor or total resistance equals to R1 plus R2. Okay. So here's the combined resistance of resistors in series. Okay. So next part is about parallel. Okay. So for parallel lamps or like parallel resistors, you can write down like this way. The total resistor equals to 1 over total resistor equals to 1 over resistor 1 plus 1 over resistor 2. This is the formula. So here, there's an example. Like we have a 3 ohm resistor and a 6 ohm resistor. We can consider it as a one kind of resistor like this way. This is 2 ohm. So here we can write down total resistance or 1 over resistance equals to 1 over 3 plus 1 over 6. So here is 1 over 2. So we can set resistance here equals to 2 ohm, okay? But this is how the lamps can connect into parallel, okay? And we can use in this way to solving some circuit problems and try to calculate them and find the current, find the voltage of them, okay? So like here, if there's an 18 voltage like battery and it connected with 3 ohm resistor and a 6 ohm resistor, right? And we can say, oh, right here, we can using the combined in series part, right? Because we can find they're in the same line. We can consider here the total resistor equals to 3 ohm plus 6 ohm equals to 9 ohm, right? So using the formula, the U equals to IR, that is almost one, right? So here U equals to the battery's voltage, here is 18, right? Equals to I is the current value and the resistance, here is 9 ohm, right? So here I equals to 2 ampere, okay? So once the current equals to 2 ampere, we can set, oh, right here, that the value of the current passes through 3 ohm and 6 ohm equals to 2 ampere. So right here, we can find for 3 ohm resistor, the total voltage is 6 voltage. And for the 6 ohm resistor, here the total voltage is like maybe for 12 voltage, right? So you can find they're always also divided the potential difference of the battery, right? Okay. So like here, there's also another example. Like here, we said, oh, I equals to potential difference over resistance. So like here, for the two parallel resistance, like we said, consider here as 0 meter and here as 80 meter. On the same line, they're the same potential difference. Like here is 18 and 0. So both 3 ohm and 6 ohm, they have the same potential difference. They are also both equals to 18 voltage, right? So using ohms law, you can say, oh, for this I1 equals to 18 voltage over 3 ohm equals to 6 ampere. And for this current equals to 18 voltage over 6 ohm equals to 3 ampere, okay? So we said, oh, total current here is I equals to 6 ampere plus 3 ampere equals to 9 ampere, okay? So here we said, oh, this is the total current value, okay? So today, this is our final part of the lesson. So I think you have to review for all the ways to understanding about the ways of connecting into series and connecting into parallels. So we just consider they're in a one resistor. So this is very easy for us to understand for these problems. Okay, see you next time. Bye.